On page 515 and 516 notes, we are going to look at solving systems of linear inequalities. So the notes before this, we graphed one linear inequality. So we looked to see if the line was dotted or solid, and then which way we needed to shade. So what we're going to have now is two or more linear inequalities. Being solved together. So when we had equations, we had an ordered pair as our solution, just one spot where when we graphed them, they intersected, or we could have used our other two methods to solve them, but our answers were always ordered pairs. What we're going to look at now is where we have the overlap of the shaded regions. So ours will only have two inequalities being solved at once, but you could have more. So what you have to think of is you are actually going to be splitting your graph into four different areas, and you will only be shading one of the four. So there's kind of two ways to go about it. One way is to graph them each separately, and then you have to go back and erase the parts that don't overlap. I don't like to do that, so I'll show you what I do instead to figure out which of the areas I shade in. So this video will go through the odds, and then you can go back and watch the evens on the other video. So for number one, these are already in slope-intercept form, so we can start graphing right away. Our top one tells us we start by going down 1 for our y-intercept, and then our slope is down 1, right 1, and up 1, left 1. We have a dotted or a dashed line. Now, instead of shading, what I would do is I draw an arrow. So since it says greater than, that tells me I would be shading above this line. And you could even put a couple of arrows on there for you. So instead of actually shading, I'll shade and then get rid of it. So normally we would shade it, okay? But instead of doing that, I'm just going to put an arrow or a couple of arrows to show which direction I would be shading. Then I graph the bottom one. So x is less than x minus 5. So I start down 5. And then I'm up 1, right 1. I can go down 1, left 1. This is a dotted line or a dashed line. Sorry about that. I'm trying to use a ruler, but it's not working very well. The good news is it doesn't matter if these cross at a nice spot or not. We're not worried about the actual ordered pair. Since this is a less than, I would be below the line. So I need to be above my first one, below my second one. So this is the spot that should be shaded. So that's what you're looking for, is that you're going to graph it and cut it into 4 pieces, okay, 4 different spots, and figure out which of those regions need to be shaded. I would not wait until the end to try to figure it out, because then you can't remember which line is which. So that's why I put the arrows. Or again, if you want to shade lightly and then go back and erase, you can do that. Let's look at number 3. Our bottom one is ready to go. So I'm actually going to graph that one first. So I'm going to go up 1 and then up 2, right 1. I can go down 2 and left 1. That is a solid line. It's a less than, so that tells me I would go down below the line. For the top, I'm going to rewrite it first. We need to solve for y to get it into slope-intercept form. So I'm going to subtract x from both sides. negative 4y is less than or equal to negative x plus 24. Divide everything by negative 4. So that tells me I need to flip the sign. Y is greater than or equal to positive 1/4 x minus 6. So I go down 6, and then up 1 and right 4. I can go down 1 and left 4. Another solid line because it's an or equal to. Again, make sure we put our arrows on the end. This is a greater than, so this would be above this line. So you can see this alleyway right here is where we would shade. If you want to check your answer ever, you would pick an ordered pair that's in the shaded region. So like you could pick 1, 1, or you could even pick 0, 0. Plug those in and make sure it works into each inequality. It's got to work into both of them to make sure it's correct. Number 5. Again, I'm going to start with the bottom one because it's ready to go. So down 2 for my y-intercept, down 1, right 1, or up 1, left 1 for a slope of negative 1. Not sure why those grid lines aren't showing up on the video. Connect those with a dashed or dotted line because it's not an or equal to. Arrows on the ends. It's a greater than, so we would be up above that line. For the top one, again, I'm going to rewrite it so I can solve it. So I'm going to subtract 4x from both sides. Again, you always move the x over, usually by subtracting. Negative 5y is greater than or equal to negative 4x minus 35. Divide everything by negative 5. Y is less than or equal to, since I divided by a negative, positive 4/5 x plus 7. So I start up 7. Normally I would go up and right, but I can't, so I need to go down 4 and left 5. That one is a solid line because it's an or equal to. And it's a less than, so down below the line, so this big region here. Number 7, they're both ready, so I start by going up 6, down 5 and right 1, down 5 and right 1. That would be a dashed or a dotted line. A less than means to the left or down. The bottom one, I start down 1, up 2, right 1. Can go down 2, left 1. That one would be a solid line because it's an or equal to. Greater than, so up above. So we're in this section over here. And number 9, what you should notice just by looking at them is that the left hands match exactly, but the right hand sides do not. So that should give you an idea of what's going to happen with these. Okay, think about what would have happened if we would eliminate, if we subtracted. Okay, so you kind of have that in your mind of what should happen, but let's take a look and see what does happen. So if I take the top one, I would subtract 3x, the opposite of y is less than or equal to negative 3x plus 6. Divide everything by negative 1. Y is greater than or equal to 3x minus 6. So I would have gone down 6, and then up 3, right 1. I have a solid line. Greater than would be that direction, up above the line. When I solve the bottom one, something you should notice again is you're solving it exactly the same. So subtract 3x. Divide by negative 1. Trying to squeeze it in here. Y is less than 3x plus 2. So I start by going up 2, and then up 3, right 1, down 3, left 1. So as you can see, we have parallel lines. So if all of you would have written as no solutions because you knew that the left sides match but the right sides didn't, you actually would have been incorrect. Since this is a less than 1, we should be shading that direction. So we are shading this alleyway in between the two. Okay, now it is possible, I'm just going to change my color here. If we would have had this to stay a greater than, all right, so we would have been over here on this one and over here on this one, then, or sorry, they would have been both the other ways. If you shade over here and over here, then you have no solutions. Okay, so it is possible if you have parallel lines, you are either going to shade in between the two, and then you do have a solution. If you shade on the outside of the two parallel lines, then you have no solution. So it is possible to get no solution for these problems as well. And number 11, we're not going to do the application one, the story problem, because we have a whole set of notes with story problems, so we're not going to worry about that one. Number 11, we have to solve both of them. Again, so the top one I'll rewrite. Subtract 7x. 4y is greater than or equal to negative 7x plus 32. Divide by 4. Y is greater than or equal to negative 7/4 x plus 8. So I start by going up 8, and then down 7 and right 4. This would be a solid line. Greater than, so up above that line. And the bottom one, x minus y, is less than negative 3. Subtract x, negative y is less than negative x minus 3. Divide, y is greater than x plus 3. We have to flip the sign. So we start by going up 3, and then up 1, right 1, down 1, left 1. This is a dotted or a dashed line because it is not or equal to. This is a greater than, so up above, so that would be this top little section here. So again, graph each one separately, decide if it's dotted or solid and which side you need to shade on, and then shade the spot that would be overlapping.